Okay, you were live.
Excellent. So, welcome everybody. I think this is the last event of this year, and I'm happy to have Vikas as the presenter. So we have a very simple agenda here. I'll take a couple of minutes introducing Vikas before I give him the mic to get to the meat of the matter and the interesting presentation he has for us. It's about the interoperability of blockchains. I'm sure you know that already. So I probably need a couple of minutes. I'll give the mic to Vikas. I think we have provision 15 minutes for his talk, and I'll give you 5 minutes to ask him any questions. But if you have any questions after the webinar, please feel free to reach him at vikaspandey.nl. I'll drop the link in the chat. Please feel free to reach out to him. He's got a lot of experience with blockchain, and that is why he's here. A quick introduction about Vikas. He's a serial tech entrepreneur and a tech aficionado. He's engaged in a lot of startups and ecosystems, especially around blockchain. He's also a co-author of a book called The Digitization of Maritime Industry. And he's got a long and impressive record in speaking and writing and publishing and establishing his thought leadership around a lot of technology topics, including blockchain and quantum computing. Without further ado, Vikas, the floor is yours.
Thanks, David and Mithun, for the kind introduction. Good morning, good afternoon, and good evening to everyone, depending on where you're based. I'm not sure if we'll cover the whole 50 minutes of the talk because it's a big topic, and I've tried to keep it some technical and some business focused. We'll see how it goes, but if we have more time, we'll do some brainstorm and question and answer session at the end. Let me start by sharing my screen and take you to the PowerPoint that I have for today.
So, Vikas, a quick question up front. You're based in Netherlands, so does the orange color have to do anything with Dutch?
It's just a coincidence, but yeah, it's a nice coincidence, right?
Impressive. Brilliant. So please continue.
Yeah. So today we are going to look at the why, how, and the what of blockchain interoperability. So it's the classic three major questions people ask in any subject, and blockchain interoperability is nothing different than all those technical topics. What we'll also see is some use cases and also how some of these challenges are being currently solved, and what does the future look like in the blockchain interoperability space. If you have any questions, feel free to stop me and ask me the questions. If I have answer, I'll give it. If not, I'll try to research and find answers to your questions. So this is how the agenda looks like today. We'll talk shortly about the why behind the interoperability of blockchains. We'll also look at some of the challenges that we currently see in the current blockchain networks or projects. We'll look at something that is called as cross-chain, which is one of the enablers of interoperability in blockchain. What is it? What is the importance of cross-chain? That's another topic we'll cover. And what are the different ways we could achieve interoperability? That can get a bit technical, but we'll still try to keep it business technical than core technical. And then we'll also talk about some notable initiatives of how different blockchain projects are currently trying to solve the problem of interoperability and the benefit that it brings, right? So what is the reason we want to achieve interoperability in these blockchain projects? We'll also see some use cases. So tech is good, but tech solving a certain business problem or a social problem is even better, as they call it. So we'll also see some use cases of interoperability in various sectors at the end of the session. And we'll also keep the platform open for any questions like Mithun and David mentioned. So let's start with the introduction. Why do we need it? So what we have seen in the last 5 or 6 years is that there has been a lot of blockchains that are exploding. So there are blockchains that are based on Ethereum there are blockchains that are based on Hyperledger. We also see at least at least a dozen of projects in Hyperledger are blockchain projects currently. We also see a lot of non-Hyperledger and non-Ethereum blockchain projects that are launched every quarter. So what has happened is all these blockchains, they have their own ledger. They store the data in the different formats, and they also perform these transactions in different ways. So in terms of the data structures that they store is also very different. Also, the amount of data that these different blockchains can process varies at a very different degree. For example, there are certain blockchains that can process 50 transactions, but there are others that can process 50,000 transactions. So there are also different networks and blockchains that are designed for specific use cases. That's also something that we will see during the presentation about specific use cases in finance, in supply chain, in governmental projects, among others, which are very domain centric. So that's also very important to try to create a common layer on top of these domains. Another reason is also the speed of development. There are different kind of blockchains that are being developed with different protocols, different technology stacks. And that is why the whole reason of the ability to communicate across blockchains, hence the interoperability problem needs to be solved as soon as we can. Otherwise, we'll end up in a situation what we saw with the old ERP systems, that a lot of the systems are unable to talk to each other, and they work in their own silos. What we'll also see today or talk about is cross-chain technology. So that's also the basis of this presentation today. Moving further, so the challenges. So one of the things that that we see are in the challenges of blockchain interoperability is most of these systems, blockchain systems, for example, talk about Hyperledger or Ethereum or Solana or Polkadot, among others. They have their own way of writing a transaction scheme. They have their own way of storing data. They have their own way of processing this data, and also the structure of the data that is used. The data structures are different, and that creates a silo, as we already heard. And these silos do not help in transforming or in transferring value of data from one system to the other. And these different blockchain platforms also have their different smart contracts. And also oftentimes what you'll see is that these smart contracts also have different protocols that they use under the hood. So all these different languages that are also used for smart contracts, sometimes written in Golang, sometimes in Solidity, the modified version of JavaScript and others, is also something that creates differences in different blockchain solutions and hence hinders the interoperability. We spoke about consensus protocols. I think most of us know about the proof of work, the classic blockchain consensus protocol. There is proof of authority, there are proof of stakes, BFTs, PBFTs, and half a dozen of them. So these also limit the possibility to form interconnections between various blockchain networks. Again, these challenges need to be addressed one after the other in terms of not just the communication, but also the processing speed of data and transactions between these systems. So a very standard definition that I picked up and modified a bit from the internet is, what is blockchain interoperability? So it is the ability to share information. And when I say information, it's not just the data, but also the metadata across various blockchain networks. It is also the possibility to seamlessly view and transact data across various blockchain networks. So today, if a certain blockchain transacts or stores data in a certain format and it has to be transferred to a different format, then it has to go through the entire, as we call it, extract, transform, and load, or extract, load, and transform process, which creates intermediaries. So that in a way defeats the whole purpose of creating a blockchain network, which was created with the intention of peer-to-peer networking instead of having intermediaries in between. One more definition is it also provides the ability to share and exchange tokens across these blockchain networks. What you'll also observe if you have been into the blockchain space for a while, that there are a multitude of tokens depending upon their value, their pegging mechanisms, the wallets on which these tokens are stored. So that also creates a lot of variety, but also challenges in interoperability. For example, ability to pay on Ethereum with Bitcoin is possible, but also on different tokens on different blockchains should also be more seamless in nature. Instead of converting a particular token from one network into a fiat currency and then converting it to a different token on a different network, that creates a lot of bad user experience, but also a lot of hassle and load on the on different blockchain networks. So in general, all of these blockchain projects that we talk about, they have one common goal. They want to create a decentralized network, which is not limited to one blockchain, but multiple blockchain networks. What it means is like, if my blockchain platform has the ability to communicate with other blockchain networks, then I can transfer the value, the tokens, the data, and also the protocol communication across these blockchain networks seamlessly. So one such technology that really facilitates interoperability is cross-chain. So what cross-chain basically does is it's a technology that allows transmission of value between different blockchain networks. So what does that mean? If I'm storing data on one blockchain, that data and its format can communicate with the data and the format of a different blockchain. And the whole logic of transforming the data and the formats are already pre-cooked or pre-solved between these different blockchains. Now, think of an Ethereum-based blockchain and a Hyperledger blockchain. In this case, Hyperledger Besu, which is compatible with Ethereum. So if you want to transfer tokens across these two systems, it is already pre-cooked into the logic of the different networks. And that is something that doesn't have to be recoded again. So there's no reinventing of the wheel in that case. These two systems can work seamlessly when it comes to the tokens and creating an inter communication between these two networks. Another topic is also the integration and exchange of logic and tokens. So a lot of smart contracts are the business logic that has been automated in code. So think of two different blockchain networks where the logic is stored in one certain way in one network and completely different in the other network. So that is also something that has to be translated like two languages so that they can communicate with each other in a more seamless manner. So that's also something that is enabled with cross-chain technology. Among others is the token, which is something like pegging the value of a certain token with a common currency or with a common token, for example, Ethereum or Bitcoin, among others. Some of the other things that we get out of cross-chain is the better user experience, economies of scale, and also eliminating a lot of technical limitations. I think we'll spend a few seconds here trying to understand this point. In terms of user experience, today, if we have to transact on different blockchain networks, we have to create multiple tokens or multiple wallets. And again, managing these multiple wallets comes with its own overheads and hence not the best user experience. If we could get a common wallet which can store all the possible tokens, then the user experience is increased to a very large extent. Economies of scale of transactions, and most of the layer one solutions, as they call it, like Ethereum, for example, they have challenges with scaling up the number of transactions. Also because they have a larger number of nodes, for example, 200,000 plus nodes, validated nodes before a transaction can complete. So with cross-chain technology, you can also achieve what they call as layer 1 plus or layer 2 solutions that sit on the main chain, and then higher transactions and throughput can be achieved with that. And that also covers the third aspect, which is the technical scaling part of the blockchains, which is not only in terms of transactions, but also the number of blocks that can be created, and number of nodes and chains that can be spinned up at multiple locations. Cross-chain also provides a bridge between these isolated systems. So what we also see is most of these systems, they have a different way of communication. With cross-chain, you can create a bridge. That's also something that we'll see across these different blockchains, but also with the main chain. So cross-chain also helps in facilitating bridge-based solutions for side chains, and also what we'll see as multi-chains or parachains. So how does cross-chain help in interoperability? So cross-chain helps, like we understood so far, it helps in enabling the exchange of value and information between various networks. So the data that we gather from the main chain to the cross chains or to the side chains as well, as we can call it, this data can be seamlessly interpreted between these chains, which always go and connect to the main chain. Or sometimes you can also choose to create a completely separate chain out of it, which is the parachain. We'll talk about it later. And hence, it is easier to exchange the value of information and the data that we get out of these blockchains. It provides a layer to scale the transactions on networks. So we spoke about layer 1, which is like Ethereum mainnet, for example. So with the help of these cross chains or side chains, we can also scale the transactions and the number of blocks that we can create per second, and hence a higher throughput. But it also lowers the gas fee. So as compared to the layer 1 solutions or the mainnet solutions, which has 200,000 plus validator nodes, in case of cross chains, you do not have to validate a transaction across these 200,000 nodes for finality. What you could also do is set up, for example, a side chain or a plasma chain like Polygon, for example, which has 100 validator nodes. So then the validation doesn't happen across 200,000 servers, but it happens across 100 servers, which results in lower gas fees, higher throughput, but also lower environmental impact. And that has also been a very big topic in the blockchain world, that the main net or the layer 1 solutions have been adversely impacting the environment because of the mining process involved. So what we also will see with the benefit of cross-chain is that business will not have to talk to only one client. The business can talk to multiple networks with multiple clients. So if a particular blockchain, which is not interoperable in nature, is running on a certain network, it will go to its client, talk to the network, and every other clients has to communicate with the network. So there's a lot of data that is being stored at the blockchain or at the data layer, sent to the client, and from the client it is communicated to the other client, and then the data is transformed and then sent it to the backend or to the ledger. With interoperability, these things can also run under the hood, and the businesses will also be able to do more efficient and optimized transactions where there's less human involvement or more automation that can come into practice. What you'll also see is that the companies will be able to transact with clients from compatible blockchains. So there are also a lot of compatibility benefits that we'll get out of cross-chain. For example, compatibility in the world of EVM or non-EVM based solutions is something that has gained a lot of ground in the last few months. We see a lot of blockchain solutions that want to be EVM compatible by design, for example, to adhere or to cater to a larger blockchain project. We also spoke about the benefits of optimization. So we'll also see a lot of reduced downtime, because you can technically spin up a side chain or a parachain or multi-chain, as you can call it, while the main network is still running, and then you have a reduced downtime, and also the transaction fees is quite less because you are paying less gas fees. In this case, because like I mentioned earlier, taking Polygon as an example, you do not have to run the whole mining process across 200,000 nodes as in Ethereum, but just 100 validator nodes in Polygon. So what we'll also say is the value transmission. So the blockchain compatibility will also help in effective value transmission across these blockchains. So it's not only just the data that can be efficiently exchanged between these two blockchain networks, but also the whole consensus and the protocols that can be mapped to each other or even shared can help in better value transmission and more optimized interoperable solutions. So these are some of the three approach how you can achieve cross-chain. You can also see the source link below. So there was an article written by Vitalik last year. I think it's a very nice article if you want to read. This is a summary of it for a quick grasp. So there are three, even more now. Now we see last few years. I'll talk about them very shortly. Sharding is one of the classical concepts in the database world, or in the ledger world, where you see that you can actually shard your database into different servers. Sharding in this case will horizontally chop your data layer into multiple databases instead of one large database, which means that you only talk to the main net for that particular shard, and then you can achieve higher throughput, but also higher performance and low gas fees with the help of sharding. It also ensures total validity and availability of every part of the system, because it is very tightly coupled to the main chain as compared to the plasma and the side chain that we'll see later. Now, since the shards are still tightly coupled with the main chain, and also these different shards are also connected to each other, there's a large quantity of data that goes through before finality could be achieved within the main chain or the main net. That's why you will see low throughput in terms of the transactions per second, or also in terms of the blocks that are created per second. In the center, we see the plasma. So in plasma, what you see is it is a side chain which doesn't hold any custody, and it is also, so if there's an attack on a plasma, the plasma can be killed by or stopped, and it still doesn't impact the main chain. So plasma in that case can sit on a layer 2 or layer 1 plus solution while still not impacting the main chain, and a new plasma can be spinned up. It also accepts local fault because it tries to limit all the consequences to that particular side chain within its own plasma. So it comes from the concept of how cells are formed in the body. Plasmas connected to the cells. So it has a very classic node and vertices concept. Since it is loosely coupled, it's also easy to deploy because you're deploying a particular plasma and not the entire set of chains together. And then it's also easy to iterate over a certain piece of side chain, the plasma in this case, and do iterations and improvement on it, and then communicate it back to the main chain. It can also offer higher privacy, like we saw in the second point, because if there are attacks, you can also kill the plasma and then spin up a new plasma and try to run and connect it to the main chain. So side chains, so all, like I mentioned in the previous slide, all side chains can be, all side chains cannot be plasma, but all plasmas are side chains. So it's a subset. So side chain, they also have the ability to agree on the validity of a transaction, very similar to what you have in plasma. The difference is this is a bit more loosely coupled as compared to the shards. So this is still connected to the layer 1 solution and has very similar features like in plasma. So you can have quick deployments, quicker iterations if you want to make any change to a side chain. And side chain primarily is suited for applications where there are low-level security threats, whereas plasma is more for solutions where there are requirements of higher privacy. Think of it like if you want to run a governmental project or a defense project, you would choose a plasma over a regular project which is not very vulnerable to security or threats. Then you would rather go with a sidechain approach. What you also see apart from shards, plasma, and sidechains are parachains. So Polkadot or Substrat, the blockchain under the hood uses parachains, which comes from the parallel processing of chips, where you see that the whole chain can be split into parallel chains and they run on their own, and also define a certain scheduling or frequency when they can communicate with the main chain. So there are these different chains running in parallel, and hence they're called parachains. What you'll also see is multi-chain. So that's an approach which is being used by Algorand. Again, very similar to the side chain or the cross chain concept. It is running a separate chain which is connected to the main chain, and it can again do quicker deployments and iterations, and it is loosely coupled for giving a better throughput and higher transaction speed. Some of the use case or some of the projects that have implemented sidechain are some of the folks of Bitcoin. Plasma is currently being implemented in a lot of layer 2 solutions or layer 1 solutions. One of the most known projects in that uses Plasma currently is again Polygon. Some of the benefits of interoperability. So now a lot of these blockchains are working in their own silos. I think the benefit that we see with interoperability, like we also saw with interoperability in applications in the past with the Web 2.0, is that you are able to efficiently share information across these different systems. And hence, in this case, with interoperability of blockchain, you can share information among blockchain networks. One special mention I would like to do here is of GS1. So GS1 is a standardization body that is working on creating an interoperability standards for blockchain, where they try to build something based on the semantics of how you store data, how you name them, and how you could share them. So interoperability, the other benefit of interoperability is to also be able to see and access information across various blockchain systems. So it's not just the ability to share information, but also the ability to create transparency. I hear some background noise. So another benefit of interoperability in blockchain is also communication across different systems. In this case, like we said earlier, we can communicate with Ethereum-based virtual machines, but also non-EVM machines, for example, Solana and Hyperledger, to name a few.
Will it go across the board, or will it be one?
Sorry? You had a question, Asan? Okay, I think it was by mistake. To continue further, interoperability, like we also saw in the previous slides, will eliminate a lot of intermediaries, because today a lot of blockchain still has to go through that data transformation or data, the whole ETL process, the extraction, transformation, load and transformation process. So if there are seamless interoperable blockchains, that process is also eliminated with the automation and efficiency that can be created. Multi-token transactions. So that is also something that are achieved by some of the blockchains today. We spoke about it earlier, such as pegging your Ethereum to a Bitcoin, or pegging your Bitcoin to a fiat currency and then to Ethereum or to other tokens, for that example, for that matter. Also, the concept of having a single wallet system for storage and transfer will create a lot of value in interoperability, but also in terms of security, the storage, but also the whole user experience can be improved if there are solutions which can provide a single wallet system. So these are some of the notable projects and their characteristics. There are a dozen of them, but or even more, but I've just tried to keep some of them for the sake of our presentation today. Polkadot, one of the quite famous projects of our time. So it uses, like I said, the parachain concepts, which have different characteristics. And they can spread over an area with the number of chains in the network, like with the parachain concept. So they are also interoperable by design, and also is based on EVM, Ethereum-based virtual machines. And they are interoperable not only within the public network, but also between public and private and public and permissionless networks in blockchain. OneChain claimed to be one of the first interoperable blockchain as a more multi-party computing, where more and more parties can set up their own side chains and commit to the main chain, but also get higher throughput. It has their own proprietary protocol for consensus, and it is again interoperable across public and private chain. OneChain also has a feature where you can transfer digital assets across different blockchains. So OneChain was created specifically for the use case of digitizing housing assets. So that's why it's a very specific use case in terms of blockchain. Cosmos, we've heard quite a lot about it. So it has the concept of zones. Zone again can be called as a side chain, but they are more having a hub and spoke approach, like you will see with a lot of these side chain and multi-chain projects, where there's a hub which is like the main chain connected with different spokes, and they are still able to get performant and consistent transactions, and they use PBFT, the Byzantine fault tolerance consensus for each zone. They also have something called as inter-blockchain communication protocol, which sends token across these zones. So in their inter-blockchain communication protocol, it is more like two different chains talking to each other, more like creating a smart contract within their blockchain to talk and transform the different tokens that are sent from one zone to the other zone. Polygon, quite famous with quite a lot of these NFT projects currently. Some of them Decentraland, for example, and Atari. It's a framework for building Ethereum-based compatible blockchain networks. So it's EVM compatible, has a lot of transaction throughput, but it's also building on non-EVM based blockchain interoperable projects currently. So they also use Ethereum-based protocol currently based on proof of stake for exchanging and completing a transaction. They have more like a port and adapter architecture, like we see in the software architecture world, where there are adapters that can be connected to the main port to enable interoperability between these networks. So some of the other projects that I could also mention in terms of doing quite a lot of work in interoperability are Hyperledger Basics by itself, which is compatible with Ethereum-based solutions for the tokens. There is Interledger, also gained a lot of attention last few years. We also have Onto Chain, which is a European Union initiative, also very dynamic in nature, because what it does is it tries to build an ontology, which is the way you define a certain thing, or the way you call a certain thing. It is a layer on top of all these blockchain networks, and based on the ontology, you can define and call or name something which can be reused across other blockchain networks. For example, ontology in this case would be like all the different networks start calling a car, then the exchange of information becomes more easier, and they also try to follow the GS1 standards for interoperability. Algorand, again, a very upcoming blockchain project. They use multi-chain. That's also very interesting, and they also follow a very different consensus algorithm, but also have a lot of interoperability initiatives in place, which is not only communicating with Ethereum-based, but also non-Ethereum-based blockchain projects in the coming period. Some of the use cases almost brings us to the end of the presentation. Like I said, we may not be able to cover the whole 50 minutes, but that's good. So some few use cases of interoperability in blockchain world. So in the healthcare world, today if there are projects where we are storing the care records on one blockchain network, but those care records are not being able to share on the other blockchain network being used by different hospitals or different government bodies. So then the whole purpose of creating the distributed system and storing the information between these two systems on blockchain is defeated. Think of it like you store the information about care records of a patient on one blockchain, and if you have to share it with a different blockchain network by a different hospital or a different country, then the whole data has to be removed out of the blockchain and then shared with the other network so that it can be saved successfully. But again, you see the problem of intermediary, and that is something that can be solved with interoperability. Also, if the logic and the data are more interoperable, then you also see efficient decision making in the healthcare systems, because all these blockchains are connected and you get better view of the different data and the communication that happens between these various blockchain networks. We spoke about user experience in the past. In this case, if these blockchains have a common wallet or a common vault, then all the information about the patient can be stored on his mobile phone with one vault or one wallet instead of storing multiple wallets or vaults for different blockchains if the patient is traveling or using different blockchain networks. It also creates trust across systems. So if one hospital stores information on blockchain and the other does not, then it is always a risk that we see where you do not, or you cannot completely trust the information that you get from a non-blockchain based system as compared to a blockchain based system. In the finance world, we also see the use case of multiple chains where different systems can talk to each other in terms of processing larger number of transactions across various banks, also eliminating the middleman. That was one of the classic use cases of blockchain from the beginning. But in terms of interoperability, then we also eliminate the intermediaries. Atomic swaps, we spoke about it. If you want to change different currencies across blockchains, then interoperability and atomic swaps can also benefit quite a lot from the interoperability initiative in that case. Finance has always been a very big topic of economies of scale in blockchain, where you cannot do enough throughput, and Ethereum was always compared with the number of transactions that was required in the Visa system, for example, with the classic centralized system. So with interoperability and with side chains, economies of scale can also be achieved with the layer 1+ or layer 2 solutions in the blockchain world. Supply chain, very similar to healthcare. So with interoperable solutions, you can also create trust among partners of the data that comes into your system. And if it is coming from a verified or a whitelisted blockchain that already operates with your blockchain network seamlessly, and the logic is pre-cooked, then you get a higher trust in the data and the exchange that takes place, but also the partners that are on the other blockchain network. So you can also have like a common know your customer or know your business process between multiple blockchain networks with the help of interoperability. So that creates extra trust, better visibility and transparency. So if we can create a solution which is interoperable in terms of storing common logs across systems, while still putting label on the different blockchain networks that they are communicating with, that will create extra visibility, but also transparency of the throughput and the volume that you get in different multiple blockchain networks. In the government and regulatory area as well, if we spoke about plasma chains, so if you want higher throughput while also creating a more secure system, we can use multi-chains or parallel chains, like we discussed earlier. In terms of e-governance, if you want to create frauds, but also want to verify different documents or different identities, interoperability will be of huge importance. because what you see today is that European Union wants to build their own blockchain network, while, for example, Singapore government has a totally different blockchain network in place. So with interoperability, this communication, data sharing, trust, and verification can become very seamless. Records management, how the records are stored across these different government bodies within a certain geography, but also across countries and nations, even continents for that matter, will start to make more sense, because then the records can be logically translated into between these blockchain networks. So think of it like a key primary key and a secondary key connection that we have in the classical database world, where there's a record and a logical translation or transformation to it between these two blockchain networks, and hence also the sharing of these records becomes way more easier between these multiple networks. Apart from it, there are more use cases, not just these four industries, but I thought it's easier to just put the most common ones that are currently in discussion. I think that would be the last slide from my end, Mithun and David. I'll leave the floor open for anybody who has any questions or remarks.
Perfect. Thanks, Vishal. I see that we have quite a few questions in the chat. Let's start with you, Martin. So Martin would like to know whether you can explain the difference between parachains and sidechains. Martin, do you want to add on to it? Well, I welcome you to come on mic if you could, and ask Vikas your questions directly to Vikas.
Or I could also answer that question, Mithun.
Perfect. Go ahead, Vikas.
So Martin, like I mentioned earlier, so parachains or parathreads, also as they call it in the Polkadot or Substrat world, is creating a replica of the main chain and running them in parallel. While in case of side chains, so side chains are not running the entire node together, but they are running a part of the nodes, but still connected to the main chain. So an example of Ethereum and Polygon, again, that I spoke earlier, is if you are creating a parallel chain, you are dividing the main network into multiple chains which can run in parallel. While in case of a side chain or a plasma chain, your main chain is always running continuously, while you create a smaller subset of that main chain and keep running it while still communicating with the main chain. I hope that answers your question. If not, you can always reach me separately.
Martin, I'll give you a minute to respond, or a couple of seconds. If not, please feel free to reach out to Vikas directly. All right. Because the next question is from Eric. He's curious to know whether the limited number of parachains at Polkadot might inhibit its growth and scale. And he'd like to know your view on that.
I think it's a good question. So it also depends on the number of parachains that we spin up, but also the communication between these parachains and to the main net, right? So indeed, if the parallel processing goes to an extent where there are more parachains than you would want to handle in terms of the transaction throughput, then it can indeed impact the overall throughput. And that's also something I recently observed with one Polkadot project, where we anticipated that we could get a throughput of 68,000 transactions per second. But when we spinned up multiple parachains, we ran into reducing the number of transactions to 1/3 or 1/4 of the transaction per second problem. Eric, you have anything to ask further?
Eric?
Thank you, Vikas. No, thank you.
All right. So Paul asks whether which of the interoperability solutions you discussed do support atomic swaps, and whether there is a need for all of them.
So there are atomic swaps currently with some Bitcoin projects. There are also with Ethereum projects, but I'm not too much into the crypto world, more into the tech part of it. So this is something that I'll have to look up and come up with the atomic swaps options that are available.
Okay, thank you so much.
Brilliant. So looking at the time, I don't know, it's the last question regarding the PowerPoint. So I'll drop Vikas' email here. Please feel free to reach out to him for your slide. Is it because David asks how you would ensure decentralization in a sidechain and a source of truth in a trustless solution.
Good question. I don't think I have a very nice or right answer to that. But I think there are also what we see is called spear phishing approach, where there are trustless. Well, trustless is not the best word to call it. It's more like data being stored in classical databases, but you can have a more spear phishing approach where you're only storing the information that you want to be secure and trustworthy on blockchain, while all the other records are connected to the classical database through pointers. That's also a project that we did for one of our American customers, where you store all your data, all your non-critical or non-blockchain specific data in a Postgres database, while you can store your data that you want to use for validation or trust on blockchain. And there is a pointer that connects between these two systems while still achieving immutability. I hope that answers your question, David. Okay. Is that it for today, then, Mithun, I guess? Yeah, Mithun, you're on mute.
Because sorry, I briefly lost my bandwidth. Any questions from any of the audience?
I see some people. Eric is ready for drinks.
Yeah. Anyway, so if no other questions, thanks Vikas for your presentation. Really compelling one. So looks like the response has been amazing. If you have a throw a look at the chat, looks like everybody has derived new insights, which is the objective of such webinars. Great shout out to you. Thanks for that. Thanks for sharing your presentation. Really compelling, really awesome. And shout out to the rest of the community members. If you have any interesting topic that you would like to present to the rest of the community, please feel free to reach out. The next session would be by a few contributors to blockchain project. So I encourage you to watch it to the meetup page. There will be an announcement showing up before we all break for Christmas. And I would really like to see you all in the next session as well. But for today, because great show, great presentation, thank you so much. And I wish you all a safe, merry, and a great time off during Christmas and New Year. Thanks, everybody.
Thank you so much.
Thanks, everyone.
Bye-bye.
Bye. Stay safe and stay hungry.
Bye all.
Bye.
Bye, David.